In the last few sessions, we have been looking at solving first order, first degree differential equations. Now let's look at first order, higher degree equations. So basically, what does that mean? It means equations with higher powers of dy by dx. Now to simplify the writing of dy by dx, because we will be writing dy by dx, dy by dx quite a lot of times, what we'll do is we'll say p represents dy by dx. At some point in solving problems, we will replace p with dy by dx. So when we say higher powers, we are talking of dy by dx square or cube or to the fourth power. Remember, don't confuse with dx square. Not this. This is the second derivative. Here it is the first derivative to the power of. Okay, and again to simplify, we'll say when I write x comma y comma p, it means it's a function or it's an equation with x, y and p, which is dy by dx. So equation comprising x, y and dy by dx. Okay. Now there are four different types we'll be looking at. We are going to look at equations solvable for p, equations solvable for x, equations solvable for y, and finally we will have or we'll look at Clairaut's form. Okay, in this session we'll look at the first one, equations solvable for p. So let f of x comma y comma p equal to 0 be the equation which we have to solve. Let's say that this equation can be expressed as the product of n factors of first degree equations. So let's say those factors are p minus f1 of x comma y times p minus f2 x comma y plus and so, not plus, times and so on till p minus fn of x comma y. So these are basically equations comprising of x, y and first degree, that is dy by dx. Okay, then in that case each factor would be 0. Now what does all this mean? See, for example, let's say I'm not going to talk of in terms of dy by dx. I'll just talk of in general a very simple equation like x square minus 1, yes, equal to 0. Now this can be factorized, x plus 1 times x minus 1 equal to 0. Now that means for this entire thing to be 0, even if one of them is 0, that is enough. So it could be that x plus 1 equal to 0 or x minus 1 equal to 0, right? So which is what this means, each factor would be equal to 0. So p minus f1 of x comma y is equal to 0, p minus f2 of x comma y equal to 0, and so on till p minus f of n x comma y equal to 0. Now here each one of these first degree equation, this is again a first degree equation, this is also first degree equation. Now if we solve each one of them let's say the solution of each of these is phi 1 x comma y comma c1 equal to 0, phi 2 x comma y comma c2, and so on, phi n x comma y comma cn equal to 0. Okay, now here c1 would be equal to c2 equal to c3 and so on up to cn. Now for the entire set of equations, there can be only one arbitrary constant, so we are saying all of these will be equal to a single constant. So therefore the solution would be of the original equation of higher degree, phi 1 x comma y comma c times phi 2 x comma y comma c and so on up to phi n x comma y comma c equal to 0. Yeah, it looks quite complicated, yes, but it's not. Let's look at a few examples. So let's look at, let's say, p square minus 5p minus 6 equal to 0. Here you have to remember that p is equal to dy by dx. Okay, now what do? We take this, we factorize it, we convert it into a product of equations. For that, let's factorize equal to 0. P 6 1 6, 6 minus 1 5. Okay, so 6 and 1, this is minus, so right. Now again, if you remember your algebra, p minus 6 is equal to 0 or p plus 1 equal to 0. Now let's put back dy by dx. So dy by dx is equal to 6, or no, let's keep it as it is. Minus 6 is equal to 0. dy by dx plus 1 equal to 0. Now what do? We integrate. Remember, we are talking of finding the solution of each of these factors. So factored equations, right? So we integrate them. So when we integrate them, we get what? Integral of dy by dx minus integral of 6 is equal to c. Similarly here, integral of dy by dx plus integral of 1 is equal to c. This would be y minus 6x is equal to, let's say this is c1, c2. So c1. And here y plus x equal to c2. Now remember, c1 is equal to c2 equal to c3. So let's y minus 6x plus c. Now you might be wondering, if I bring c1 to this side, it should become minus. But remember, we are substituting c1, c2 with c. Okay, c might be equal to a negative number. Okay, now y plus x plus c is equal to 0. Remember here, y minus 6x minus c1 equal to 0, y plus x minus c2 equal to 0. So we can combine this in this form. So this is the solution for p square minus 5p minus 6 is equal to 0, where p is equal to dy by dx. Okay, let's look at the next problem. X dy by dx square plus y minus x dy by dx minus y equal to 0. Okay, first thing we'll do is we'll say p is equal to dy by dx. So therefore xp square plus y minus x p minus y equal to 0. Okay, xp square plus yp minus xp minus y equal to 0. So let's group them and take out common. So here p is common, so p plus y. X is also there, so xp plus y minus xp plus y is equal to 0. So here it will be 1. P minus 1 times xp plus y is equal to 0. Now what this implies is either p minus 1 is equal to 0 or xp plus y equal to 0. Now let's again bring back dy by dx minus 1 equal to 0 and let's integrate. So when we integrate we get y minus x equal to c 1, and here this would be x dy by dx plus y equal to 0. Now let's separate out dy dy and dx, separating the variables. So x dy is equal to minus y dx. Okay, so let's separate out the variables. So this becomes dy by y is equal to minus dx by x. Let's bring it to the same side. Dy by y plus dx by x equal to 0. Now let's integrate. We get dy by y plus integral of dx by x equal to, let's hold on to that constant for the moment. This becomes log y plus log x is equal to, now whenever we have logs, the constant also we treat it as log. So this would be log c2. Now again, log rules, we can write this as log xy is equal to log c2. Now to get rid of this logs, we exponentiate all the terms. So this get cancelled and we are left with xy minus c2 is equal to 0. So now we have two equations. So their product would give us the solution to our original problem. So the general solution would be, now let's say c1 is equal to c2 is equal to c. This is not e, this is c. Okay, so the solution would be xy minus c times y minus x minus c is equal to 0. Y minus x minus c is equal to 0. So this is the solution. Let us do one more problem. So let's say p square plus 2px minus 3x square is equal to 0. So let's first split the middle term. So p square, let's split it 2 px plus 3px equal to 0. So here if you see 3px minus px is 2px. Okay, so now we take out common. P minus x plus 3x p minus x is equal to 0. P minus x times 3x p plus 3x. So this part you can treat it as pure algebra, factorization part. Now this we can write it as p minus x equal to 0, p plus 3x is equal to 0. Now we integrate. So this would be integral of dy by dx minus integral of x is equal to c1. This would be integral of dy by dx plus 3 times integral of x is equal to c2. This would be y minus x would be what? X square by 2 is equal to c1. Here y plus 3x square by 2 equal to c2. Again y minus x square by 2 minus c1 is equal to 0. Y plus 3x square by 2 minus c2 equal to 0. Okay, now let's treat c1 equal to c2 is equal to c. The solution would be y minus x square by 2 minus c times y plus 3x square by 2 minus c is equal to 0. So that is the solution. I think that's enough. Bye for